Okay, now let's look at example 7. Determine the net torque on the 2 meter long uniform beam as shown in figure at point 3. Calculate about point C, the center of mass of the beam. Point C as pivot point, and then point P at one end, point P as pivot point. Okay, so now we want to calculate the net torque. Okay, di mana kita dibagi dua pivot point. Satu at point C, which is here. So point C ni adalah at the center of the mass of the beam. And then point P, which is at here. Okay, so when we're talking about the net torque, we know that it is the sum of the torque. Okay, so now kita ada 3 point. Okay, 3 point di mana there is a force apply. So dekat sini point 1, point 2 dan point 3. So now we know that the sum of the torque is equal to torque on point 1 plus torque on point 2 and then torque on point 3. So now depending on the pivot point, okay, kita kena identify dekat mana akan jadi sama dengan kosong. Okay, so when we have point C, which is point number 2 actually, point 2 as pivot point, okay, the torque here will be equal to 0. So T2 will be equal to 0. Why? Because according to the formula, which is RF sin theta, dan R dekat sini adalah distance daripada pivot point. So kalau dekat T2, because we want to find T2, right? This one dekat pivot point ni. So distance daripada pivot point adalah sama dengan kosong. That's why the torque on the pivot point will always be equal to 0. Okay, so ingat saja dekat pivot point torque akan sentiasa sama dengan kosong. Okay, so now untuk soalan A, kita hanya ada T1 plus T2 because T3 because T2 adalah sama dengan kosong. So now kita akan kira T1 and T3 first. This one and this one. So T1 is equal to RF1 sin theta. So R here is the distance daripada pivot point, daripada sini ke sini. So since C adalah at the center and the length of this beam is 2 meter. So kita tahu daripada sini ke sini adalah 1 meter. So you just masukkan 1 meter. And then F1 adalah sama dengan 56 Newton. And then the angle must be the angle between F and R. So R kita macam ni, F kita macam ni. So this is the angle actually. 30 degree. So you will get, okay, tekan calculator, you will get 28 Newton meter. So this one adalah magnitude. We need to identify the direction. So direction untuk torque either clockwise ataupun anti-clockwise. Ada dua sahaja. Dia either clockwise ataupun anti-clockwise. Di mana untuk clockwise it will be negative, anti-clockwise positive. This one kamu kena sentiasa ingat ya. Okay, so how can we determine this direction? Okay, kita tengok dekat sini F1, direction dia dah ke sini kan. Maksudnya kita apply force ke atas beam ni ke sini. So apa yang terjadi adalah beam ni dia akan rotate macam ni. So dia akan jatuh ke bawah macam ni. Pada sini kan initially. So kita apply force. So dia akan jadi macam ni lah. Dia akan rotate macam ni. Like that. Okay. So it will rotate like this, which is anti-clockwise. Clockwise. So dia akan rotate macam ni. So this one is clockwise. So clockwise negative. So kamu kena tambah negative. This one clockwise. Okay, and then second one is T3 at this point here. torque 3. RF3 sin theta. So radius still sama, which is daripada pivot point ke P adalah 1 meter juga. And then F3 is 52 Newton. And then sin theta. Theta adalah angle between F and the value for R, which is 60 degree. 60 degree. So tekan calculator, you will get 45.03 Newton meter. And then direction dia pula. So when we apply the force here, what happen is the beam will rotate this way. Okay, kita apply force ke sini kan. So beam tu dia akan ke bawah lah macam ni. So maksudnya dia akan rotate macam tu. Like this, it is actually anti-clockwise. So clockwise, which is positive. So positive here, anti-clockwise. So now, tambah macam biasalah, this one. The sum of the torque is negative 28 plus 45.03, which is equal to 17.03 Newton meter. So kita dapat positif, bermaksud dia adalah anti-clockwise. Okay, since torque is a vector quantity, so we need to always leave the question with magnitude and direction. Okay, sama juga final answer macam ni. Kena start lah either clockwise ataupun anti-clockwise. Jangan letak positif sahaja. Mesti start either it is clockwise or anti-clockwise. Okay, so that's the first one, which is pivot point dekat C. Now kita punya pivot point adalah dekat P. So soalan B, pivot point dekat P. Okay, which is here. Now let me padam this one. Okay, pivot point dekat P. So meaning that here, okay, torque 3 adalah sama dengan kosong. So torque 3 is equal to 0. So now kita akan dapat the sum of the torque adalah sama dengan, the sum of the torque is equal to T1 plus T2. Okay, we cannot use the same value here because now kita punya value for R is different. Okay, because value for R adalah distance daripada pivot point. So now untuk T1, you need to calculate again. RF1 sin theta. So now kita punya value for R adalah daripada point ni ke point ni, which is equal to 2 meter. So 2 times F1, which is 56. Okay, angle is still the same, 30 degree. So you will get 56 Newton meter. And then direction still sama sebab kita punya force still sama, which is negative. And then torque 2 is equal to, so from here to here is 1 meter, and then force 65 Newton. And then sin 45. And then you will get 45.96 Newton meter. Okay, now the direction. So we apply the force here. So what happened is, okay, dia macam kita angkat lah beam ni ke atas. Okay, dia akan macam kita angkat dia ke atas macam ni. So dia akan rotate like this. Okay, it will rotate like this, which is anti-clockwise. So anti-clockwise. This one lebih baik untuk kamu cuba dia menggunakan pen ataupun pembaris macam tu. So kamu akan nampaklah pergerakan dia tu macam mana, adakah clockwise ataupun anti-clockwise. So this one is anti-clockwise, so positive. And then kita just tambahkan negative 56 plus 45.96. So you will get negative 10.04 Newton meter, which is clockwise. Since dia adalah negative, it is clockwise.